So let's pull together a summary of these various mechanisms of tropical cyclogenesis that we talked about. You can actually think of them as possible mechanisms because mostly they are empirical relations and don't actually explain the end-to-end evolution and formation of the incipient vortices. Okay, so previously identified for a long time, it's been known that monsoon trough and El Nino were playing a big role. There were also mentions of African easterly waves for a long time. One of the original ideas of how hurricanes were born from these wave features and associated mesoscale convective systems, and the quasi-biennial oscillation, which puts in a signal from the stratosphere into the troposphere and also has associated convection signals. We also think of that in the case of MJOs and how stratospheric tropospheric interactions produce various other patterns of surface weather and so on. So here, tropical cyclogenesis, African easterly waves, monsoon trough, and mesoscale convective systems, and modulating influences were argued to come from El Nino and quasi-biennial oscillation, which is still very much the case. So here we are looking at sources of tropical cyclogenesis and modulating influences recognized in the late 20th and early 21st century. So the impact of MJOs, which is not mentioned here, for example, is added here, and these equatorial Rossby waves and mixed Rossby gravity waves are not necessarily independent of MJOs because the associated convection. So MJOs are originating generally on this side of the Indian Ocean and propagating eastward, sometimes detoured southward, and so on. But nonetheless, there are other ways of generating equatorial Rossby and mixed Rossby gravity waves from tropical diabatic heating, which is one of the main sources here, as well as the ITCZ breakdown, which happens here, and it's the Indian Ocean side of the ITCZ, which exists here throughout the year because the Indian Ocean is warm. During the monsoon season, it splits off, so you get a cyclone season here during that time when the ITCZ is still active here. And what else? Yeah, so here we have the subtropical storms that we discussed and how the elevated heating and vorticity can come down to the surface and initiate an incipient vortex, which can then evolve and grow, as happened in one of the tropical storms, I think Hurricane Diana, probably. We can look it up. And we talked about the Saharan air layer and the African easterly jet together interacting with the African easterly waves as well. And African easterly waves are also now recognized to cross over into the Pacific and interact with the ITCZ breakdown and make it all the way into the monsoon trough and the confluence region that we talked about here. So all these are, again, often just empirical ways of taking a cyclone that is already recognizable, born of a certain intensity, let's say a tropical storm, and then track it back in time and look at what features were present and whether they were favorable for the survival and evolution of that incipient vortex that could have been born from one of those mechanisms. El Nino is worth looking at because it reorganizes SSTs on a very large scale and convection on a large scale, as well as circulation and associated cyclogenesis parameters like the ocean heat content, vorticity, relative vorticity at the surface, vertical motion, mid-tropospheric humidity, and so on. So the idea now is extended from just saying El Nino to types of El Nino, or what is now referred to as El Nino diversity or flavors of El Nino. This is called the East Pacific El Nino. This is called the central Pacific El Nino, or warming around the dateline, also referred to as El Nino Modoki by the Japanese scientific groups. La Nina, where you have cooling on the east instead of the warming, so it's the enhanced seasonal cycle of some sense. And then there is the difference of CP minus EP, which looks this way, where you have during the Central Pacific El Nino cold anomalies here. Whether this pattern is becoming more prevalent and whether that's related to global warming, and then are debated. And then there is the impact of global warming on the cyclogenesis itself in terms of the changes in thermodynamics and dynamics of the global ocean atmosphere system. So just to add a little bit more details in terms of what we already looked at. So during the Central Eastern Pacific, you can have strong warming and wind anomalies, and obviously you will shift the ITCZ, create warming quite far up the west coast of North America and South America, and you change large-scale circulations, and there is our favorite monsoon trough that we looked at, and the so-called confluence zone that we talked about between the ITCZ. So ITCZ is moving, monsoon trough is either getting stronger and more extensive or is shrinking, as you can see here, and approximately it is showing the intensity and the tracks of cyclones, number of cyclones, etc. are also modified by this. So both El Nino and La Nina can affect the cyclogenesis, the extent of the region of cyclogenesis, number of cyclones born, and their tracks and intensities are all modified. So you can see the East Pacific El Nino and the West East Pacific El Nino pattern, where the warming happens. There is a weak warming here, and there is a weak cooling here. Okay. Over the Atlantic, we saw this early on in the course. We are looking at tropical El Nino, typical El Nino influence, fewer hurricanes due to stronger vertical wind shear and trade winds and greater atmospheric stability. So more hurricane here due to less vertical wind shear, and here you have the shifted warm pool and warm wet climate here, especially for the South American and North American regions having anomalous rainfall, mudslides, reduced upwelling, and so on and so forth. A typical La Nina influence here produces more hurricanes due to weaker vertical wind shear and trade winds, and reduced atmospheric stability, which is always favorable for the vortex to grow and convection to happen. Before, we didn't talk so much about when we talked about the various processes. Convection is always something that is going to reduce stability by creating vertical motions, but also tends to reduce vertical shear. So there is a feedback involved there that we should have more carefully discussed, but you can think through that in all of the contexts that we discussed. Fewer hurricanes due to stronger vertical shear on this side, with cool and dry conditions, anomalously cool and dry conditions here. Even the Indian Ocean is argued to, there is evidence that Indian Ocean cyclogenesis in the post-monsoon season is affected as well. This is for El Nino years, and this is for La Nina years. So you can see La Nina years, typically cyclones have longer tracks, more intensity, more in number, whereas this is for October, November, I think. And during the El Nino year, you can see that the cyclones are born much more towards the west, and they have a shorter track, and maybe there is a systematic difference in the tracks as well. That there is definitely a difference in the intensities. So that's a good example of how a low frequency climate mode reorganizes the necessary conditions for cyclogenesis, and the models are now beginning to try to forecast cyclogenesis. I'll show a figure. I didn't include it. Let me pause this and restart. So from the time of Bill Gray, the U.S. has been issuing seasonal hurricane outlooks. For the 2021 forecast came out recently in May 2021. The season starts on June 1st and goes through November 30th, but we will see that the season is being redefined. So the forecast for 2021 calls for an above normal year with 60% chance and 30% chance of being near normal in terms of number of named storms, and there is a very small chance that the season is going to be below normal. So the forecast has now become probabilistic. There's always been an argument whether this method works at all, but nonetheless people eagerly await this forecast before the season starts every year. The forecast also says there will be 13 to 20 named storms, so that's quite a large range. Hurricanes strength, there will be 6 to 10, and 3 to 5 of those will be major hurricanes. 2020 was a record year that tied a record that was previously set in 2005, which included the infamous Katrina. Because of global warming and the changes in ocean atmosphere conditions, the average Atlantic hurricane season effective 2021 is now changed in terms of the average numbers. So from 1981 to 2010 there used to be 12 named storms on average, 6 hurricanes and 3 major hurricanes. Now there are 14 named storms, 3 hurricanes and 3 major hurricanes for 1991 to 2020, and there is of course evidence that they are traveling slowly, they are intensifying rapidly, they are stalling near the coast, and so on and so forth. So we will visit some of the details of how cyclones may be responding to global warming later on in the course at the end.